Hello, my name is Maria Valadez Ingersoll, and I'm a PhD candidate at Boston University in the Department of Cellular and Molecular Biology. This past summer, I did my urban internship at the University of New Hampshire with the New Hampshire Sea Grant, studying the dynamics of dispersion of the invasive pathogen Vibrio perihemolyticus. Vibrio perihemolyticus, which I will refer to as VP, is a bacteria that is found in coastal and estuary environments. It can be found free living in the water or as part of the microbiome of oysters. Some strains of VP are pathogenic, meaning that they can cause disease in humans, and some of the pathogenic strains are more virulent than others. This means that they're more able to infect and cause that disease in humans. One of the more virulent strains is called ST36, which became established in the Atlantic in 2012, and it came from the Pacific Northwest of the US. Since 2012, there have been lots of policies put in place to try to limit the spread of this dangerous variant, many of which limit the capacity for oyster growers to diversify their product. This limitation is harmful to the growers, especially in the face of a growing market. The oyster industry in New Hampshire alone was worth $4.7 million in 2021 and $3.7 million in ecosystem services because of the oyster's ability to filter pollutants from the water. So it's evident that this is a very important system to the state of New Hampshire. Because of the combined importance of the growing demand for oyster and the increasing risks of VP disease, there's a pressing demand to understand how VP spreads across habitats, establish itself in oyster microbiomes, and how these dynamics will change under anthropogenic climate change. At UNH, we are using a technique called whole genome sequencing to study VP strains and to improve VP detection techniques. We use whole genome sequencing to analyze different VP isolation and culturing techniques and to look at VP populations across the Great Bay Estuary in New Hampshire. As I mentioned before, VP is part of the oyster microbiome, which is the community of bacteria, viruses, archaea, and fungi that live in different tissues of the oyster. In the future, we will use techniques that I've been helping to develop to study how the oyster microbiome interacts with VP and how this microbiome shifts under environmental challenges. With that, I'd like to thank the Urban Program as well as Boston University and the University of New Hampshire for helping me develop this really awesome project that I've learned a lot of really great new techniques. Thanks so much.